Hey everybody, and welcome to another deep dive. We love to get our hands dirty with some seriously cool research, and today we're tackling biomechanics,
Oh, yeah.
the science of how our bodies move. And we've got a fascinating report from 2015
It is a fascinating one.
that tested out this device called the Kinetic Link. That's pretty interesting stuff.
Absolutely. This report comes out of East Carolina University's biomechanics lab, and they were really interested in seeing how wearing this kinetic link device on your legs can impact a bunch of things,
Like what kind of things?
like muscle activation
Okay.
and even jump height.
Whoa, okay, so we're not talking about some run-of-the-mill fitness tracker here. This is like next level.
Yeah, this could be big.
So for those of us who, maybe skipped biomechanics class, what exactly is this kinetic link thing?
Well, think of it as this external device that you wear on your legs. And the researchers in the study actually got clever and decided to test it out in two different spots.
Okay.
Above the knee and below the knee. They wanted to see if placement made a difference. That's smart. So it's not just does it work, but like how does it work depending on where you put it?
Exactly.
I like it. What kind of movements were they looking at with this thing on?
Well, they tested a whole range of movements from, basic stuff like walking and running to more complex things like jumping and hurdling.
Oh, wow. Okay.
They wanted to see how the kinetic link impacted muscle activation across all these different activities.
Okay. I am officially intrigued. Let's get into the nitty-gritty. What did they find?
Well, one of the first things they noticed was that just standing still while wearing the kinetic link actually caused people to lean forward a little bit.
Really? Just standing there? That's kind of weird.
It is.
Yeah.
But when you think about it, it kind of makes sense. Similar to how like a heavy backpack shifts your center of gravity forward.
Right.
The kinetic link seems to have a similar effect.
So are we talking like full-on Michael Jackson smooth criminal lean here?
Not quite that dramatic.
Okay.
The average forward lean was about 3.5 degrees, which is actually less than what you might see with a heavy backpack.
Oh, okay. So subtle, but still measurable.
Yeah.
And that's just from standing. Can't wait to hear what happens when we add some movement into the mix. What about walking, jogging, and running?
Okay, so here's where it gets even more interesting. Across all those movements, they found a consistent increase in activity in two major muscle groups. The rectus abdominis,
Okay.
which are your abs,
Yes, the abs.
and the gluteus maximus, your glutes.
So you're telling me this thing basically gives you a core workout while you walk around?
Well, it's not quite that simple, but the results are definitely interesting.
Okay, I'll bite. How much of an increase are we talking?
They found an average increase of 44% in abdominal muscle activity
Whoa.
and 37% in glute activation.
That's wild. Okay, now I'm curious about the specifics for each type of movement. Did they notice any differences between like how the kinetic link affected walking versus running?
They did. They analyzed things like step length posture, even specific joint angles.
Oh.
And when it came to step length, it actually varied. Sometimes it got shorter, sometimes it got longer, depending on the movement and placement of the kinetic link.
So no clear pattern there. What about other things like posture? Did that forward lean we talked about carry over into these dynamic movements?
Yeah, it did. They observe that forward lean continuing, especially at the moment of heel strike. It's like the body is constantly adjusting to the presence of the kinetic link throughout the whole walking or running cycle.
That's so interesting. So your body has to kind of figure out a new way to move efficiently with this thing on.
It seems that way.
Okay, you mentioned earlier that they had specific data points for male jogging. What did they observe there?
Yeah, they looked at knee flexion and thigh angle while jogging. And with the kinetic link, they actually found greater knee flexion when the forward leg was reaching out.
So it's almost like it was encouraging a slightly deeper bend in the knee during that part of the jogging motion, even if the overall step length was relatively consistent. Wow, okay. My mind is already buzzing with all this biomechanics stuff, but I'm ready for more. What about those more complex movements you mentioned, like the jumping and hurdling?
So for those, they had participants do hurdling, skipping, and even two types of jump roping.
Two?
Yeah, the jump rope run and the straight leg jump rope.
Wow, they really covered all the bases.
They did.
Okay, so did that increased abdominal activation we saw with walking and running carry over to these more challenging movements?
Yes, it did. Across all these activities, the kinetic link consistently increased rectus abdominis activation. A strong core is important for just about everything.
It really is. Now tell me, were there any like quirky, unexpected findings specific to these more specialized movements?
Definitely. For instance, during hurdling, the participants wearing the kinetic link They actually had a more upright posture and less flexion their trail leg as they cleared the hurdle.
So it's almost like the kinetic link was helping them maintain a smoother, more controlled movement over the obstacle.
Yeah, it's possible.
And what about skipping? Anything weird there?
Skipping was interesting because wearing the kinetic link below the knee
Yeah.
actually resulted in a longer step length.
Really? That's the opposite of what we saw with running.
I know it's strange.
Bodies are weird. What about jump rope? Any surprises there?
Jump rope was more in line with running. The kinetic link generally led to shorter steps,
Okay.
regardless of whether they were doing the jump rope run or the straight leg jump rope.
So we're seeing some patterns emerge, but there are definitely these like little curveballs that keep things interesting. What do you think explains these variations, especially when it comes to something like step length?
It probably comes down to the complex interplay of, forces muscle activation and individual biomechanics. Each movement involves different muscle groups, different joint actions.
Right.
It makes sense that the kinetic link would impact them in slightly different ways.
It's fascinating. Okay, now for the main event, jumping.
Here we go.
This is where I imagine this kinetic link really shines, right?
Yes, this is where the potential of this device becomes very apparent.
So the report dives into a few different types of jumps, but one thing that really jumped out at me
Pun intended.
was this consistent finding of higher ground reaction forces when people were wearing the kinetic link.
Yeah,
Now, I know this is like a key concept in biomechanics, but for those of us who need a refresher, can you explain what ground reaction forces are and why they matter?
sure. So imagine you're jumping off the ground, you're pushing down with a certain amount of force, and the ground is pushing back on you with an equal and opposite force.
Right.
That's ground reaction force.
Okay.
It's basically measuring the force exchange between your body and the ground during movement.
So a higher ground reaction force means a more powerful jump, potentially.
Exactly. And that's what makes this finding so exciting, especially for athletes who are looking to, you know, boost their performance in activities that require explosive power.
Like sprinting or jumping.
Exactly.
That's incredible. So let's break down the specific types of jumps they analyzed in this report. They looked at vertical jumps, single leg jumps, drop landings, followed by a vertical jump, and box jumps.
Right. Let's start with the classic vertical jump. What did they observe when people were wearing the kinetic link?
This is where things get a little paradoxical.
Right.
Because while wearing the kinetic link, people generated higher ground reaction force.
Meaning more power.
Yes, but they also showed less trunk and knee flexion during the counter movement.
Wait, hold on, back up. The counter movement, for the biomechanics newbies out there, what exactly is the counter movement?
So the counter movement is that initial downward movement, like bending your knees before you explode upwards in a jump.
Okay, got it.
Anyway,
So they were jumping higher with less bend in their knees.
right. It kind of challenges what we think we know about how we generate power for jumping.
Totally. And was that trend of a straighter knee and a more upright trunk, was that also observed in the single leg jump?
It was.
Fascinating. It's like the kinetic link is somehow tapping into a different kind of power, or maybe engaging different muscles in a way that compensates for that reduced range of motion.
Yeah, it's really okay, what about the drop landing followed by a vertical jump? Any surprises there?
That one was interesting because they observed an increase in ground reaction force. So a more powerful jump,
Okay.
but a decrease in gluteus maximus activity.
Wait, so the glutes were working less even though the jump was more powerful?
Exactly.
Yeah.
It really highlights just how complex these biomechanical interactions are.
For sure.
The kinetic link might be shifting the workload to other muscle groups. Or maybe it's changing the timing of muscle activation in a way that results in greater power output. More research is needed to figure that one out.
Okay, last jump, type the box jump. What happened there?
So this one was fascinating because from a purely visual standpoint, the movements with and without the kinetic link looked pretty similar.
Oh, okay.
But there was a significant increase in both abdominal and glute activation.
So same basic movement, but the muscles were working a lot harder.
Yes. And that increase in muscle engagement likely explains why they were seeing those higher ground reaction forces. It seems like the kinetic link is consistently making those core and glute muscles work harder, even if the movements themselves look the same.
That is incredible. So as we kind of wrap up this part of our deep dive, what are some of the big picture findings we should be taking away from analyzing all these different movements?
Well, a few key themes are emerging. First, the kinetic link seems to lead to shorter step lengths in most gaits.
Okay.
Second, it encourages that forward lean during walking and running, but a more upright trunk when prepping for a jump. And third, it consistently leads to those higher ground reaction forces in jumping, suggesting greater power output. But maybe the most important finding is this consistent increase in both rectus abdominis and gluteus maximus muscle activity across all these different movements.
Wow, it's crazy how one simple device can have such a profound impact on how our bodies move and activate muscles. But we are not done yet. Join us for part 2 of this deep dive, where we'll delve deeper into the potential applications of this technology, from athletic performance to injury rehabilitation. It's going to be fascinating.